or a couple people online, so that's good.
So okay, let's start. Can you hear me clearly?
Yeah, we can hear. Well, I mean, at least here. What about the people online?
Oh, okay. Okay. I'm Yi Yang. I'm from Inspire Cloud in China. We want to use Opendaylight as SDN controller in our public cloud. So I investigated Opendaylight and find some critical issues for scalability. In this topic, I will talk about audio controller clustering issues and source bound plugin issues and VXLAN issues and other MISC issues. For controller clustering, if you check cluster CSIT suite, you can see HIL2 robot and HIL3 robot are always filled. Actually, it's a clustering issue. Maybe it's a ARCA issue. Maybe it's a application issue. So somebody argued it's an applications issue. Like Red Hat guys, they said Genius have many issues for this. They have filed many bugs for Genius and the network. Basic issue is MD-STIL issue. Actually, some applications don't use correct MD-STIL API. For example, for transaction, if application just you write transaction and submit something, then it doesn't close this transaction. So if we have many this situation, we will run out of memory because the transaction memory is memory leakage. For scalability, Red Hat guys also run many test cases in their lab. They have filed many issues in Opendaylight Jira. So far, I can see some issues are fixed, but there are still many issues are there. Yeah. Another issue is Red Hat guys proposed use managed transaction API. Michael developed this and changed many places in Genius. But in Genius, there are still some components which don't use this managed transaction API. So that's the root cause of HIL2 and HIL3 failure. If you want to see details, you can access these genres. For scalability, actually, in our data center, we plan to deploy 2,000 nodes to 10,000 nodes. So we need to we need many ODL cluster nodes to handle this big workload. But in current setup, there are 3 cluster nodes. If we want to scale this number to 127, I don't know it can work. At least per my investigation and discussion with Robert and Neil, they said it cannot work. Actually, in current cluster design, for one module, for example, inventory data store, actually only one node is leader shard. Leader shard will handle every read and write. Even the read request is from other cluster node. So in current cluster design, it is more like data replication, not distribute the workload to different cluster nodes. So if we have 127 cluster nodes, actually the only one cluster node, it's inventory and network topology node is handling all the read and write operations from every node. So actually, shard leader is bottleneck for this. I discussed this with Robert. I think if we can control shard separation method. For example, we can split inventory data store to many shards. Each shard for some source bound device. For example, if we have 100 OpenFlow plugin clusters, I think every OpenFlow plugin cluster can be responsible for handling one shard. Maybe it can improve scalability, but currently ODL cannot handle this. Actually, about 2 or 3 years ago, Python guys introduced the prefix-based shard, but it's not ready for use currently. Another issue is I also discussed with Robot. Can we set up ODL cluster in symmetric mode? That means maybe one node is for northbound and southbound. Some other nodes are for southbound only. For that case, maybe we can improve something. Robot Robot told me it's okay theoretically, but when I tried this, it cannot work. Actually, every node cannot start it normally. For backend, some guys proposed to use the database. I remember VTE guy proposed anti-data store project, but I don't think this can handle scalability issue. I think it's just for backup for data store. For source-bound plugin scalability, in cloud data center, actually most of workload are from computer node. In data center we have many computer nodes. So actually, inventory and network topology data store are very big. For my evaluation, if I only use 3 nodes, we have about 2 gigabytes inventory and 2 gigabytes network topology data store. So if we have 10,000 computer nodes, okay, this data store is very big. In OpenFlow plugin cluster design, actually, OpenFlow plugin also use clustering. It's different from audio clustering. Actually, in OpenFlow plugin cluster, generally we have 3 nodes there. One is master, 2 are slave. Master can do read-write inventory store and do flow statistics and handle asynchronous messages from source-bound device. But slave node only can do read operation. Actually, in these 3 OpenFlow plugin nodes, any node cannot do write and read operation locally, because actually we only have 1 leader shard in audio cluster, right? So actually, OpenFlow plugin cluster node just do read and write from leader shard node. So it's a remote operation. So I think for source-bound node, we can just run source-bound protocol. For example, for cloud data center, we can only run OSDB and OpenFlow plugin in source-bound node. In that way, we can save memory, right? We can handle more compute nodes in one OpenFlow plugin cluster. Actually, OSDB also use similar mechanism. So I just make sure, can you hear me now?
Yeah.
Okay.
Can you hear me?
Yeah.
Okay, good.
So currently audio controller cluster is not ready for super scale data center. Actually, I just try to design a new cluster way to handle this situation. Actually, in OpenStack, we have some neutron servers and many compute nodes, right? Actually, even in our super scale data center, neutron servers are not so many. Maybe it's the number about 10 or 50. So neutron server just call northbound API from ODL node. So I think we can run northbound and southbound in these ODL nodes. It's not so many. For southbound, we can do horizontal scale per compute node scale, right? If we add more compute nodes, we can scale southbound node to handle them. We don't need to add new neutron a new node for neutron server. Here the issue is the southbound node needed to push some data store message to neutron node because if a compute node do some change, well, for example, if we and manager for OS BI interbridge, actually northbound some service need to get this and write configure that. So in southbound we only run OSDB and OpenFlow plugin, so they cannot handle them. ODL node for neutron servers also will write all the configure data in that store, then synchronize them to southbound node. So southbound node can listen there and get any change and take action to configure compute node. Actually, I also checked some commercial products. Here are Huawei Android controller for DCN and ZTE controller. they also use the similar way. For Huawei controller, actually they take some components from ONOS and some components from Opendaylight. So it's a mix of ONOS and Opendaylight. Here you can see for master node, they only have two, node 1 and node 2. In this node, they run everything. You can see database, northbound proxy, clustering, cache management, etc. But in this node, node 3, they only run message queue stuff, no northbound, right? So for ZT controller, it also uses the same way. Here they have two master nodes. These two nodes are active passive mode. For northbound, they can scale them to 128, right? So if we have more and more compute nodes, they just scale source-bound controller. For master controller, they still have two nodes there. So I think this way is more scalable than current ODL clustering design. Here is a presentation from Anil. Anil talked this in OS Los Angeles. Actually, they also proposed a similar way. Here, they want to use a message bus. It's Kafka or RabbitMQ. For northbound, for southbound, they only run OpenFlow or Netcore protocol. For northbound, they just run RESTConf A and network service. This cluster will synchronize that by message bus. So southbound cluster can get them. Here they also propose the external data store. Maybe it's a database. So I think almost important providers are using a similar way to handle scalability, especially horizontal scalability. They also proposed the use container to run Opendaylight. Currently Opendaylight just run a standalone application, right? So maybe we can split this standalone application to many microservices. We can run every microservice in different containers. In that way, we can deploy them more conveniently. For VXLAN scalability, actually, currently, Opendaylight cannot handle them. They use it uses full mesh VXLAN tunnels currently. Actually, OpenStack Neutron has a L2 population plugin to improve scalability, but currently ODO cannot support this. Ericsson guys are working on improving this, but currently it isn't done. But in my local machine, I fixed some issues, so I can do this currently. Let's demonstrate this. Here is my OpenStack and Opendaylight integration setup. It's done, so I just show. Here you can see VXLAN port. We only have one VXLAN port here. Here we don't set destination IP. It's a flow. That means we use OpenFlow to change destination IP per flow. Actually, in this setup, I have 3 compute nodes. Here, this is the control node. I run Nova and OpenStack control part in this. This is compute node 1, compute node 2. In previous ODL, actually, here we should have 2 VXLAN ports. One is for compute node 1, another is for compute node 2. Here, destination IP is compute node 1 IP and compute node 2 IP. But when enable OpenFlow tunnel in IT direct tunnel component in Genius, we only create one VXLAN port for every other compute node. So, for example, here if we have 10,000 nodes, compute nodes, we still have one VXLAN port here. We don't need more VXLAN ports because we can use OpenFlow to change the destination IP. So by this way, actually we can scale this to any compute node, right? Let's check compute node 1 here. Only one VXLAN port here. Actually, by Ericsson guys, some patches and my local changes, it can work well. Here is the compute node 2, only one VXLAN port. Here let's check VM communication. Here I started 4 VMs. This is in control node. This is in computer node 1. This is in computer node 2. This also in computer node 1. Here I enabled SNAT, and for VM4 I enabled floating IP. So here we check floating IP is okay. Right, it's okay. Let's check SNAT. Here we message to VM2. Here we pin VM1. It's okay, right? We pin VM3. It's also okay. Let's pin external website. For example, pin Baidu.com. Right, it's okay. Right, so SNAT can work well. Let's pin Tencent. It's also okay. Let's check floating IP. You can see it's okay. Actually, it's a VM4. Right, VM4. IP here. Right, let's pin Baidu. It's okay, right? Let's pin JD.com. It's also okay. So for VXLAN scalability, I think we have fixed them. But for other MISC issues, actually, Opendaylight controller use much memory. Per my test, here I only install OSDB source bound and OpenFlow plugin source bound. You can see total virtual memory size is about 6 gigabytes. This is resident memory. It's about 1.5 gigabit. I think it's very big. For a number of threads, you can see only for OSB source bound and OpenFlow plugin source bound, we have 112 threads there. I think it's too big. Actually, in this controller, I didn't connect any source bound device. Here, I install ODL-network-OpenStack. You can see what's the number of threads. It's about 300, right? So it's very big. But for memory size, it's similar to source bound only case. So I don't know why. So actually, Python developed Lite.l to fix these issues. They identified these issues as slow startup, too many threads, and too much memory. They removed the curve totally, so controller can be started faster with less memory. Here you can see their data. For startup, if we use the light.l, only 3 seconds, but for Opendaylight, it's about 14 seconds. Especially for build time, right? For Opendaylight, it's about 1 minute. Actually, I think it's maybe in US. If in China, it's very slow because repository for artifacts are in US server, so it's even bigger. For build side, it's a jar package. If we use light.l, it's about 70 megabytes, but for Opendaylight, it's 300 megabytes. So it's about 4 times, right? For memory usage, you can see the gap is very big. So I think maybe curve is culprit. Actually, Red Hat guys also identify these issues. They tried to use juice to replace curve. Juice is a lightweight dependency injection framework. By juice, actually they can improve startup time. Michael created Opendaylight simple project. Actually, if you want to try, actually it can run only POC. It cannot run network and how. So I think for these issues, I think it's they are very important for production. If in production environment we have these issues, I think it's not acceptable. Summary. So I think ODL controller clustering is not stable, not reliable, and not scalable. ODL is also not container friendly. For source-bound plugin scalability, it's bad. VXLAN scalability is bad, but we are doing this. Startup time is big. Memory consumption is big. Especially ODL has so many threads. So I think many threads means consume many CPU resource and memory resource. So I think we need to improve them. I call for action. If ODL community hope to push audio controller to cloud data center, I think we need to take efforts towards these directions. If we can fix these issues, maybe cloud data center can use audio controller. So my topic is finished. So any question? Hello?
No, I don't have any questions.
Okay.
No. No. All right, no questions in here.
Okay. So we can finish.
People online, I haven't heard them in a while.
Okay.
So what do you see as the problem with the stability?
That was early on in the discussion,
Yeah.
before you got here. But yeah, you can, if you have time, you can go back and answer that. Did you hear him?
Yeah. So what's your question?
Just on the stability, is it the control plane pieces or is it the basic functionalities that break down when you start pushing the system? Because we've seen this at a few guys trying to do these kind of larger deployments. Is it the container pieces or is it the kind of generic functionality or the customer?
Sorry, I didn't get your question. So what's your question?
Basically, what I'm asking is the instabilities that we were talking about. How much of that is the kind of generic interfaces versus just that it wasn't designed for Kubernetes from the start?
Sorry, you mentioned the Kubernetes.
Yeah, container friendly, so to say. You mentioned the second bullet here that ODL is not container friendly.
Yeah.
So how much of these problems are connected to that it's not friendly to containers versus that there are pieces that are not kind of designed well or tested enough from the start, even with VMs doing kind of clustering.
So you mean if we use Kubernetes to deploy ODL, maybe we can fix some scalability issue?
Yeah, or what do you think that the problems come from? Does it come from the original design, or does it come from kind of Kubernetes and these new systems with slightly different setups on a kind of stable system for existing functions?
Okay, I don't think so. Actually, even Light.io split controller to many microservices, but the clustering mechanism is still Akka-based, right? So I don't think it can fix clustering issue. It's a design issue. Not by some container methods can.
Thank you. Now I understand what you.
Yeah.
If we don't have any questions, then we can end 10 minutes early. My question? No? Good. Yi, I think we're good to go.
Okay,
Unless
okay,
you-
okay. We can done.
Okay. Thank you, Yi.
Thank you. Bye.
Bye.